Good evening, everyone. So, last class we discussed about this slide and we skipped some portion. So, a function g is called the inverse of a function. So, if there is an inverse of a function, it is denoted by the sign f inverse, like that. Okay? Understood? So, that's how we denote an inverse function, right? So, if we have the inverse of g, so it will be denoted as g inverse. Now, the second line is very important thing. Listen, read it carefully. Further, g is also 1, 1 and onto, and the inverse of g is f. What do you mean by this thing? The meaning is that what we see is that if I do the inverse of a function, then the function which we get, that is the inverse of that previous function, is 1, 1 and onto, right? So whenever I told you that whenever I get a function that is 1, 1 and onto, I can get an inverse of it, right? So I can get the inverse of g. Look at here. Wait a second. Just look at this one. So g function you see, which is the inverse of f, is 1, 1 function, 2 to 1, 3 to 2, 4 to 3, 5 to 4, 6 to 5. It's also 1, 1 function. And onto function, because 1, 2, 3, 4, 5 are images of some elements of the set B, right? So that g function, since it's 1, 1 and onto, it also has an inverse. We can find the inverse of that thing also. And the inverse of that thing will be, it is very simple. The inverse of that thing will be f, the function which we got the inverse of. Suppose I say 2. What is the inverse of 2? It is 1 by 2. Now in the same way, what is the inverse of 1 by 2? It is 2. Am I clear? Okay. So that's what it says. The inverse of g is f function. Okay, then you can write f function as g to the power minus 1. Understood? I hope you guys are very clear about this one. Now last line you see, that's the most important thing. Trigonometric functions are not 1, 1 and onto over their natural domains and range, so their inverses does not exist. So what they mean is that we are discussing this chapter that is inverse trigonometric functions. Now obviously we need to find inverse of trigonometric functions, but what we see is that the trigonometric functions are not 1, 1 and onto over their natural domains and range. So natural domains and range means what? The domain and range which they actually have. In that domain and range, trigonometric functions are not 1, 1 and onto. So their inverse does not exist. So one thing, if their inverse does not exist, then what the point of this chapter, right? It's totally reject the notion of inverse trigonometric functions. Understood? Achha, for example, you see, what is the value of sine 0? Sine 0 is 0, right? Now in the same way, can you tell me what is the value of sine 180 degree? That is also 0. You see, two elements, that is 0 degree and 180 degree, has the same image. Understood? Okay, let's discuss that thing in this diagram form. I hope everybody is very well accustomed about this arrow diagram thing, right? That's why I'm going to try to explain this thing in terms of arrow diagram. Achha, one thing, this thing we are discussing is our sine function. Okay, we will be doing that. Why sine function does not have inverse in its natural domain and range. Understood? Clear? Yeah, wait a second. We'll just be doing it. So suppose I take a value 0 degree. Okay, understood? Now sine 0 is how much? Sine 0 is how much? Sine 0 is 0. Clear? So the 0 element of the set A is mapped with the 0 element of set B. So I will write this one is a function, sine function. Okay, so it is sine. Now you see 180 degree. Now if I write 180 degree, okay, so 180, sine 180 is also 0. Understood? Yes or no? Sine 180 is also 0. So if it is also 0, then what we can say? Then we can say that the sine function is not 1, 1. Am I clear? Sine function is not 1 1, and since it's not 1 1, we don't have to show for onto. Then we can directly say that the inverse of sine functions will not exist. Clear? So if this is what happens, then what we do? We should leave this chapter in here. So this is the end of this chapter. No. Clear? So the thing which we will discuss is that how to restrict the domain of a sine function, how to restrict the domain of a sine function to get that 1 1 and onto thing in its domain and range. Understood? We will be restricting that if the domain is from minus, if the domain is real numbers, then we will be cutting that domain a very, very small portion to a very, very small portion, so that it makes the sine function a 1 1 and onto. Okay, so now we have a graph of sine function. I hope we are well aware with the graph of sine function. I'm very sorry about that. So here let's do the marking. Here we have 0. Here we have the sine is maximum, so it is at pi by 2 sine is maximum, sine 90 is 1. And here we have pi because sine is 0 at 180 degrees, so pi. And here we have minus pi, where sine is minus 1. Sorry, 3 pi by 2, I'm very sorry. It's minus pi will be that side. So it's 3 pi by 2, and here we have 2 pi. From the diagram only you see 3 elements, 0, pi and 2 pi have the same image, right? Yes or no? So it's not 1 1. Clear? And this side will be minus pi by 2. You see minus pi by 2 and 3 pi by 2 have the same image, not 1 1. And we have minus pi. Minus pi will be just beside minus pi by 2. Okay? Wait a second. Let me write that thing, minus pi. And the next one, it will be minus 3 pi by 2. And you see minus 3 pi by 2 and pi by 2 have the same image. Clear? And this side will be minus 2 pi. Understood? So what we see in here, this graph, there is a portion of the graph which is repeating after every interval, right? Yes or no? So I will try to cut a portion of graph which is not repeating and which has all the possible values of sine function. So can anybody tell me what is the range of sine function? The range of sine function is what? Range is actually what? The values of y. What is the minimum value of y we see, and what is the maximum value of y? We see the minimum value of y is minus 1. You see at minus pi by 2, or you can see at 3 pi by 2, the minimum value is minus 1 and the maximum value is 1. Understood? So the range is minus 1 to 1. So I have to restrict the domain of sine function such that I get all the possible values from minus 1 to 1. Understood? And let us have that domain closer to the origin. Okay, it's very, very necessary thing to have the domain closer to the origin. It's a general way to define. And let us do that thing. So can anybody guess where it will be? Where should I cut so that all the possible values of sine functions are there? Look at it carefully and tell me where minus 1 to 1 is there. So here we can see the range is minus 1 to 1. Okay. So let's try to cut the graph. So think carefully and tell me, where should I cut? Where should I cut the graph so that we can get now look at it carefully. So if since it is closer to the origin, so the portion where we will cut is from you see the maximum value is 1 there and the minimum value is downside of y. So we have to have those two values, all the values within minus 1 to 1, where minus 1 and 1 are included because it's closed bracket. So minus 1 and 1 has to be included. If I have to cut the portion, then minus 1, 1 has to be included. Understood? So there are 2 points I have to keep in mind. One point is that it has to be, the 0 origin has to be included. Understood? And the points minus 1 and 1 has to be included. Okay, so let's see which portion should we cut in here. This is a very, very important thing. What we are doing actually is we are making sine function a 1 1 and onto function. Okay, that's what we are doing in here. So let's see how do we cut this one. Now you see, if I draw up two lines from pi by 2 and minus pi by 2 like this, you see this is the portion of the graph which shows us all the possible values from minus 1 to 1. Understood? So this is the portion in which the sine function becomes 1 1 and onto. Understood? Am I clear? This is, we can have many portions like that, but it is very, very necessary to have it closer to 0. And this portion from minus pi by 2 to pi by 2 is known as principal value branch. This portion is known as principal value branch. So minus pi by 2 to pi by 2 is known as principal value branch. Okay, so x has to be an element of this thing. I hope everybody clear about this one. How did we make a sine function into a 1 1 and onto function? The reason to make this one, so that in the future we can find the inverse of that function. Am I clear? Okay. So copy it down, everyone. Please draw the diagram. The diagram is very, very important. The most important thing is the concept. Okay. You just memorize things, but it's better to visualize a thing. Memorization is good for something, but in mathematics, in your science subject, the concept is important. You don't want to memorize everything. You just remember the concept. Understood? Suppose you see 2 plus 2. Will you memorize 2 plus 2 is equal to 4? What you will memorize? That plus sign. Okay? The addition. Because if you remember the addition, then you can do 3 plus 5, that is 8, like that. Okay, don't memorize everything. Try to get the concept of it. Achha, now let's try to do the cos function, and I hope everybody is well aware of the cos function. It is same as a sine function, but it's shifted. Okay, since sine function has maximum value at pi by 2, cos function has 0 at pi by 2, and it has maximum value at 0. Okay, the same range is same, minus 1 to 1. So we have to cut a portion of cos function in such a way that it becomes 1 1 and onto. So which portion should I cut? So you see the domain is R. R means what? The x values are increasing from the left hand side and right hand side. Okay, so we have to cut a portion such that the domain is, the function is 1 1 and onto. So let's see who can guess it. And the domain has to be very, very closer to the origin. Okay, it has to be closer to the origin, or come on, let's see who can tell me. So here we have pi by 2. Yeah, let's do the markings. And then we have this one as pi. This one is our pi, and this one is your 3 pi by 2. You see 3 pi by 2 and pi by 2, cos function repeats its value, right? So it is not a 1 1 and onto function. So we have to make it. And how do we make it? By cutting a portion of it. So this side we have minus pi by 2, and then we have minus pi. And we all know that cos of minus x is cos x, right? You see cos of minus pi is equal to cos pi. That's how it is. Yeah, you see, if you visualize the thing, how cos of minus x is equal to cos x, you visualize that thing and you get your answer. This thing you will remember. You don't have to remember the formula. You just visualize. So which portion should I cut? Now most of you will be thinking of, if I cut minus pi by 2 to pi by 2, it's wrong. Why? Because you see the graph looks like the same. In here only positive values are taken. If you think of y, only the positive values are taken. The negative portion is totally ignored if I cut a portion of this one. So minus pi by 2 to pi by 2 is wrong. So which portion should I cut to have both the positive and negative value? That is from 0 to pi pi. If you cut the curve of cos function from 0 to pi, then you see that all the positive and negative values are included. So what is the principal value branch of cos function? It will be 0 to pi. I hope everyone is clear about this one. Okay, so that's how we make cos and sine function as 1 1 and on 2 by restricting its domain. Okay.